Volcanologists were once again surprised by the extraordinary activity of natural forces at work beneath the Earth's surface. On the 10th of November 2025, two astonishing geological phenomena occurred almost simultaneously on opposite sides of the planet. The massive eruption of Steamboat Geyser in Yellowstone National Park, United States, and the ongoing eruption of Kīlauea Volcano on the Big Island of Hawai. Although separated by thousands of kilometers and differing in characteristics, these two events were of significant interest to researchers because they demonstrated how geothermal energy can be released simultaneously in various forms through superheated water on one side and through molten lava on the other. In early November, Yellowstone's geothermal monitoring system recorded an increase in hydrothermal pressure in the Norris Geyser Basin area. Seismic sensors detected small tremors and a rise in ground temperature, indicating the movement of hot water toward the surface. 2 days later, in the early morning of November 10, Steamboat Geyser, the world's tallest geyser, erupted, spewing steam and boiling water more than 300 feet into the air. The eruption lasted for almost half an hour, accompanied by a rumbling sound recorded by monitoring instruments within a radius of several kilometers. This event immediately attracted the attention of researchers from the U.S. Geological Survey (USGS) and a team of scientists at Yellowstone National Park. Based on initial observations, this major eruption was one of the most powerful in the past 2 years. Thermal sensors near the site recorded a rise in surface temperatures of over 80 degrees Celsius, while underground pressure measurements indicated a gradual energy release pattern after the eruption ended. Volcanologists explain that Steamboat Geyser's activity results from a complex interaction among groundwater, hot rocks, and a high-pressure steam system that forms deep beneath the surface. When underground pressure reaches a threshold, a column of hot water is forced upward, producing the spectacular eruptions characteristic of this geyser. This phenomenon is a form of natural energy release that demonstrates how heat from the Earth's interior seeks an outlet through Yellowstone's hydrothermal system. At nearly the same time, about 5,000 kilometers from Yellowstone, in the middle of the Pacific Ocean, Kīlauea Volcano was once again displaying its natural splendor. Episode 36 of the Halemaumau eruption ended abruptly at 4:16 p.m. Sunday after nearly 5 hours of dazzling lava displays. The northern vent stopped spewing lava around 3:38 p.m., while the southern vent, which had previously been erupting at 1,000 feet, decreased to 500 feet at 3:48 p.m. It persisted for a while before gradually fading, finally ceasing altogether at 4:16 p.m. The show culminated when the lava plume reached an astonishing height of between 1,000 and 1,100 feet, a molten spectacle to awe the eyes. This episode produced an estimated 10 to 11 million cubic yards of lava, with a combined eruption rate of over 650 cubic yards per second from both vents, the highest recorded in the entire eruption. Lava flowed rapidly, covering approximately 60–80% of the Halemaumau crater floor, seemingly repainting the face of the Earth with liquid fire. This powerful eruption was not only a sight to behold, but also triggered significant changes in the surrounding landscape. A towering column of smoke and steam blanketed the sky, forming a thin curtain of ash that spread with the wind. Scientists at observation posts recorded fluctuations in pressure and temperature, trying to understand the dynamics of this extraordinarily active magma. Around the crater, new fissures began to appear, sending small lava flows that infiltrated the mountain's slopes. Each lava flow resembled a river of fire, slowly but unstoppably carving a new path across the Earth's surface. This phenomenon served as a reminder of the unpredictable power of nature, at one level fascinating, at the other potentially dangerous.